will be doing solubility experiment. That means how compound dissolves in different solvents. We already know that some solvents dissolve some compounds, right? And that doesn't dissolve some other compounds. So what is the principles? We already discussed what are the principles for dissolving the solute in the solvent. The basic principle is very simple, like dissolves the like. Like dissolves the like, that is what you have to remember. Now, that means polar compounds dissolve in polar solvents. Non-polar compounds dissolve in non-polar solvents. So that is the basic. Then there are some other rules, we don't have to worry about that right now. So let us only focus on these two principles. Polar compounds, polar solvents. Non-polar compounds, non-polar solvents. So all we have to do is we have to identify what are polar compounds, what are non-polar compounds, what is polar solvent, what is non-polar solvents. I have already explained that based on the electronegativity of the atoms, how to identify any compound, given compound, is it polar or non-polar, right? So we already know that. So now in today's experiments, we are going to show these three compounds: benzophenone, biphenyl, malonic acid, and how they will dissolve in this water, methanol, hexane. So now let's take a look at this benzophenone. If you look at the benzophenone, whether it's a polar or non-polar, well, you look at this benzene structure here, right? Two benzene rings, one keto group. That means there is a small polar moiety here, but there are big non-polar hydrocarbon. There is a C6H6, that means it's non-polar. Hydrocarbons are non-polar, right? So non-polar, non-polar, polar. That means this is kind of semi-polar, neither polar, not heavily polar compound. So it's intermediate. Biphenyl is completely made of carbon and hydrogen. So you can definitely say this is non-polar compound, biphenyl. Malonic acid, here carboxylic acid, only one small CH2 group, which is hydrocarbon. So we can say it is very highly polar. Look at the solvent now, this water. Water we already know it is polar because H2O, right? And methanol is kind of polar, but not as much as water. Hexane is a hydrocarbon, so it's non-polar solvent. So I'm going to demonstrate at least one of these compounds, biphenyl. So our expectation is that biphenyl should not dissolve in this water because water is polar, non-polar. So no, it won't dissolve. And biphenyl may dissolve a little bit, but not much in methanol because it's polar, non-polar. Biphenyl is supposed to dissolve in hexane because it's non-polar and non-polar. So as we say here, non-polar compound dissolve in non-polar solvents. Okay. So you can same way predict and do the experiment for all these three compounds. So let us do one now for the biphenyl. Experiment now is to show the solubility of the biphenyl, where is it? This biphenyl in water, hexane and methanol. So already I labeled the test tubes and I already added 40 milligrams of the compound. This biphenyl, can you see white powder here? This one is, test tube number 1 is water. Test tube number 1 is, second is methanol, I labeled. Third one is hexane and fourth one is for the reference. Okay. So there are 4 test tubes, added 40 milligrams of biphenyl. Now I'm going to add, and these are called pasture pipettes, and this is the bulb for 1 ml. So I will take the water one and add water. So this is water, right? Let me add 1 ml. See this 1 ml here, and add 1 ml. And then I'm going to shake this here. You can see this, it doesn't dissolve. We'll come back and see again one more after 1 minute. But right now, adding water doesn't dissolve, it just suspends. Now, I can't use the same pipette, this water, right? So I'll keep it here. Second one is methanol. Where is methanol? Methanol is here, methanol. I'm going to add methanol 1 ml, right? Again, can you see here? It doesn't dissolve, but there is a little bit, it looks like. I mean, you have to compare to the reference compound. You can still see something undissolved here. Maybe a very little solubility. So number 2. Again, I have to change the pipette to a new one. What the third one is hexane, right? It's a non-polar solvent. Biphenyl is non-polar. We expect that to dissolve. I'm not sure. Let us see. Okay. Let us see. I'm adding 1 ml actually. Okay. So you just tap it just to dissolve them because they are crystals. It takes a while. When the compound is crystalline, it takes a while to dissolve because they have to break the crystal lattice. See? You can see now pretty much everything is dissolved. Right? And fourth one is what? Reference compound, this much, right? So now we come back and check water. You can definitely say, you should give a 1 minute time because the crystal has to dissolve all. So there is definitely, as we predicted, biphenyl does not dissolve in water because non-polar, this water is polar. Methanol is slightly polar solvent, so it dissolves partially, but still you have a lot of, you can see here, a lot of things have left in methanol. So we say partially dissolves. Let us see hexane. Well, there is one crystal left, but you can say it dissolves. Okay, it dissolves. Okay, so in hexane, biphenyl dissolves, whereas in methanol it partially dissolves. In water does not dissolve. So we prove a point that non-polar solvent and the polar solvents, and this is the reference. Okay, so that completes one compound, and you are supposed to do the other ones, malonic acid, benzophenone, the same way. Take those compounds in the test tubes, add the solvents, and check the results. Okay.